Welcome to Primitive Archer TV. There's an app called BowSet Calculator, and what it does is it helps you lay out a bow to take a calculated amount of set or no set. So let's just tap that and get right into it. So you'll notice the first thing you see up here is your wood specific gravity. That's going to be the specific gravity of the type of wood that you're working with. You Google the type of wood you're looking for. In our case, I'm going to use Osage, so I'm going to type in 0.86. That's the higher end of the spectrum for Osage. I make my bows out of a higher density if I can help it. And I like to make 50-pound bows, so we're going to go with 50. And when I hit calculate, we're going to find out how many square inches this bow needs to be in order to make a 50-pounder with 0.86 density wood that'll take no set. And I need 34.5 square inches of working wood inside the limb. Working wood would be the wood that's bending. It doesn't count a stiff handle, it doesn't count stiff tips or stiff recurves, etc. So the next portion of this gets into, so this is the hypothetical on top. On bottom is your real world bow, what you're actually building. So your height is going to be how far up past the beginning of where the wood starts to bend. Now your wood on a stiff handle bow starts to bend in the fade. About halfway up the fade is a fair estimate. In a bendy handle bow, your height will be right in the middle of the handle. But because this bottom half is nothing magical here, it's just an area calculator. You can't multiply anything by 0, which is what you would think your starting point would be, because when you multiply by 0, you get 0. But if you multiply by 0.001, then you can actually get an accurate area. So for the bow that I'm laying out currently, I'm going to start this width at 2.5 inches. Then I click Add Dimension, and it runs parallel at 2.5 inches up 3.5 inches. And then, so we're going to enter 2.5 there. Now that defines the rectangle with parallel limbs. Then I'm going to hit Add Dimension. And we've got to go up 8.7. I hate it when I do that. There we go. Click the right button. We're going to go up 8.75 inches. And the width there is 2 inches. They're going to continue further on up the limb to 11 inches. And at that point, it is 1.75 inches wide. We're going to go up again to 18.25 inches. And the width there is 1 inch. Now we're going to hit Calculate Area. When I hit Calculate Area, this top button populates at 34.75. That's, quarter inch more surface area than I require. So that's close enough to call it good. And I'm on the positive side of things. Now down here, you got to hit the Calculate Area button a second time, and it will calculate how much set the bow will take. This bow is calculated to take a negative amount of set because I am overbuilding it by 0.72%. So percent difference, that's where it tells you if you're overbuilt or underbuilt and by how much. So long as you're taking negative set, you should take 0 set. If it says positive set, then you'll find yourself taking set. So if I were to remove this line right here and then hit Calculate again, we see that with that area removed, I'll be taking 1.57 inches of set, and I'm 39.23% underbuilt. So we're going to bring back this 18.25 with a 1 inch calculate area again to get the bottom to populate, and that's how this build is going to go. Now, getting a little further into the top portion of this calculator, it's really neat because it works forwards, backwards, and sideways. And what I mean by that is we've already demonstrated that if you want to know how much surface area your bow would require to be perfectly balanced with the number of square inches in the limb and its poundage, you have that field empty, you hit calculate, it gives you your area. But what if you know that you've got a 0.86 density wood and you don't know what poundage the bow can make? Well, you leave the field blank that you want to calculate, you hit calculate, and it will tell you the poundage that the bow needs to be. And likewise, you can also calculate what the specific gravity is by filling out your poundage that you want to build, how much surface area you have to work with, and it'll tell you the density of the wood required to make that bow. So if you don't have any Osage available, you can look at other woods that are also 0.86 in density in order to make your bow. All in all, it's a pretty accurate, actually it's a very accurate app, very handy, and it will help you increase the performance of your builds and take away the guesswork when you want to build a hypothetical bow and see what it'll do without actually having to build a real bow. Now in this case, obviously I'm laying this out on an Osage stave. This is a 56-inch long bow and it's going to pull 50 pounds. I'm taking it to a flight shoot here in a week. So I'm going to be building this bow and to this calculator app, and we're going to see how well it performs with high performance distance shooting and speed. So this will be a real world test of this calculator. A little more about this bow design. As you can see, I'm running nice parallels, but I got this knot here that I had to avoid, because if you cut a knot on the edge of a bow, what you're going to have is you're going to have a terrible weak point and it'll break there. So I had to dodge it, but that decreased my length between here and here, how wide I could make it. So using that app really allowed me to figure out, all right, I have no choice but to shrink it from here to here to 2 inches, but I was 2.5 over here, so tapering it to miss that knot. And then I had another defect I wanted to dodge right here, and then that gave me with a taper to miss that 1.75. Now that's a lot of math to do by hand when you just type it into your calculator. And then it told me with the aid of that app how wide and the distance between here and this tip to make it so that I can gain the square inches that I need so that this limb can be the required width. So when you're dodging deformities and defects, like I've got this knot cluster here, I went as wide as I could while dodging coming up above this one so that it's not on the edge of the bow, but still going below this one so that it's not on the edge of the bow. I was really limited in geometry here, so using that app helped me lay out the geometry of this bow so that I can dodge the defects and still come out on top with the required amount of surface area. So now I'm able to build this bow with confidence, knowing that I'm not going to overstress the wood.